Hello students, in this video we are going to discuss the next testing of hypothesis part. So in this particular video we are going to discuss about the paired t-test and the f-test. So paired t-test is basically the continuation of the t-test for the difference of mean, but we can use paired t-test when we are instead of the two independent sample. Here we are having dependent sample, that means where we are going to measure the two different observation of the same samples, so the samples are paired together. So in this case what we are going to study in paired t-test for difference of mean. So first case is we are considering that the sample sizes are equal and the two samples are not independent but the sample observations are paired together, xi yi. Now the problem is to test if the sample means it differs significantly or not. Okay, so in this case what will be the our test statistics. In this case the test statistics will be xi minus yi, that is we are considering di bar upon capital S upon square root of n. Okay, where di is equal to xi minus yi and capital S square is the variance, the deviation variance, that is 1 upon n summation I varies from 1 to n di minus d bar square. Or instead of capital S we can use the notation of small s also, because we know the relation between capital S and small s is s square is equal to n s square upon n minus 1. So in that case we can use the relation that s square upon n is equal to small s square upon n minus 1. So it means that s upon square root of n is equal to small s upon square root of n minus 1. Okay, so on the basis of that we can either use this statistic or we can use the statistics as s upon square root of n minus 1. So in that case what is the formula of small s square? It is 1 upon n summation di square minus a di bar square also. So this is the test statistics in this case. Okay, so to understand this particular concept, so let us firstly start with the problem. Okay, now the question is, a certain stimulus administered to each of the 12 patients result in the following increase of blood pressure. So can it be concluded that the stimulus will be in general be accompanied by an increase in blood pressure? So in this case already we are given the increase in a blood pressure value, means we are given the value of the deviations. So deviation is increase in value, means the after the stimulus there will be increase in a value, that is yi minus xi we are given here. Okay, it's fine. So this is the value we are given here. Okay, so the data is given in the form of a deviation only. So what will be the null hypothesis? Null hypothesis is mu1 minus mu2 is equal to 0. That means there is no change in a blood pressure after this stimulus. And what is the alternate hypothesis? Alternate hypothesis is mu2 minus mu1, because we are given the change value only. So mu2 minus mu1 is greater than 0. That means result in the increase in a blood pressure. Increase in blood pressure. So basically it is a right tail test, right? So because level of significance is not given here, so we are assuming here the level of significance alpha as a 5%, and because in this case we are given a sample of size 12 only, so we are going to use here the t-test for the difference of mean. So because in this case we are having only one sample with the two different observations, so your degree of freedom will be n minus 1, that is 12 minus 1 is 11. So we need to check the value of t at 5% level of significance and 11 degree of freedom. So if we refer the t table for the same, then we can get the value of t at 5% level of significance and for one tail test 5% level of significance, one tail test, and as well as the at 11 degree of freedom. So its value is 1.796. So its value is 1.796. So its value is 1.796. Now the next step is we need to calculate the test statistic. So the test statistic is t is equal to di bar upon small s upon square root of n minus 1. Okay, so we are given this particular data. Here we have used the Excel for the same. So let me show you here. So how we have used this particular data. Suppose I'm considering here the value of di, means the difference is given here as 5 5 2 8 minus 1 and then 3, then 0, then minus 2, then 1, then 5, then 0, then 4, and then 6. So this is the value of d. So the first step is we need to calculate the mean value. So I'm taking firstly the sum of all these observations. So I'm calculating their sum using the command of sum here, control shift down. So its sum comes out to be 31. And how many observations are there? This is the sum, right? And if we want to calculate the mean, then I need to simply divide it with, this is equal to 31 divided by 12. So its value comes out to be 2.5833. So this is the value of mean. Now to calculate the variance, firstly I need to calculate a d square. So here I am calculating the square of all these number. So like 5 square is, so I am taking the square of this number. 5 square is 25, 2 square is 4, 8 square is 64, and so on. So its sum comes out to be, if we consider this command of sum here, then its sum comes out to be 185. So what is the formula of variance? And the formula of variance is equal to that is small s square equal to 1 upon n summation di square minus a d bar square. So it is equal to 1 upon 12 into 185 minus 31 by 12, it's a square. Okay, so if we even use the calculator for the same, we can use the Excel or we can use the calculator for the same also. So what I need to do, I need to firstly calculate 185 divided by 12 minus bracket 31 divided by 12 bracket close, it's a square, and then we find out the difference. So its value comes out to be 8.743056. So its value comes out to be 8.743056, right? And now if we take the square root of this particular number, then that will give us the value of standard deviation. It is 2.9569. So what is the di bar? It is 2.583 upon its value is 2.9569 into square root of 11 is in the numerator. So if I calculated this value, so what I need to do, I need to take the reciprocal of this number, multiply it with 2.583 and multiply by square root of 11. So its value comes out to be 2.89. So its value comes out to be 2.89. So this is the calculated value, and the tabulated value is so calculated value is 2.89 and the tabulated value is 1, which is greater than the tabulated value 1.796. And because it is a right tail test, this is the critical value 1.796 and this is the region of rejection, right? Like this is the 1.796 and this is the region of rejection, and because 2.89 is greater than this one, so this value falls in the region of rejection. So it means that null hypothesis rejected. So null hypothesis rejected means the stimulus result in the increase in blood pressure. So what is the conclusion here? The conclusion is the stimulus result in increase in blood pressure. So when we give this particular stimulus to the patient, then their blood pressure will rise. So this is the solution of this problem, right? Okay, let us try the another problem based on t-test also. So in this case, the question is, in a certain experiment to compare the two types of the animal food, the following result of increase in weight were observed in animals. So we are given eight animals, and when we are given food A, then their weight is increased by 407, and when we are given food B, then the increase in weight is 423. Examine the case when the same set of 8 animals were used. Now this is the important point. So if we are using two different set of animals, then we need to use the difference of means, that is independent two samples. If the two different set of animals were used, okay, but what it is given here, same set of 8 animals was used. Okay, so it means that these two set of animals are same only. Okay, so we want to see that either with food A the increase in weight is 407, with food B the increase in weight is 423. So we want to check that either this difference is significant, can we say that food B is better than food A, or we can say that there is no significant difference between two. So what will be the null hypothesis in this case? That there is no significant difference in the increase in weight. And what would be the alternative? That food B is better than food A. So it means that the average increase in weight with food B is greater than the average increase in weight with food A. So it is a left tail alternative. So the level of significance we are going to consider here, alpha is equal to 5%. Degree of freedom, because here we have used 8 animals, so 8 minus 1 is 7, because we have a same set of animals. That's the reason degree of freedom is n minus 1. Okay, now the next step is we need to calculate the test statistic. So the test statistic is T is equal to di bar upon small s upon square root of n minus 1. Okay, so firstly we need to calculate the difference of these two. 49 minus 52 is minus 3, 53 minus 55 is minus 2, 51 minus 52 minus 1, 52 minus 53 minus 1, 47 minus 50 is minus 3, 50 minus 54 minus 4, 52 minus 54 minus 2, and 53 minus 53 is 0. So we sum up 3 to 5, 6, 7, 3, 10, 14, 15, 16. So this value comes out to be minus 16. So what is di bar? This is summation di by n. So minus 16 by 8, its value is minus 2. And then we have calculated square. So what is s square? 1 upon n summation di square minus d bar square. So 1 upon n means 1 upon 8 into di square, its value is 44, minus of minus 2 square. So its value is 5.5 minus 4, so its value is 1.5. So this is the value of s square. If the value of s square is let me show you here, it is 44 divided by 8 minus bracket minus 2 square is 2 square only. Okay, so it is a 4, so its value is 1.5. If we take the square root, then its value is 1.22. So if I substitute this value here, so d bar is minus 2 upon 1.2247, and square root 7 is in the numerator. So if we calculate this particular data, let me add one more slide. So the value of t comes out to be minus 2 into square root of 7 upon 1.2247. Right. So what is the value of t comes out to be? Let us calculate this. So we take the reciprocal of this number, multiply by 2, multiply by square root of 7. So its value is 4.32 minus 4.32. Okay, but what is the value of t at 5% level of significance and 7 degree of freedom? The value of t at, okay, so we need to refer the t table for the same. T table right tail left tail test means it is a negative value because it is given here a positive side only, right? So we are going to refer the right tail, and because t distribution is a symmetric distribution, then we multiply it with a negative sign. So with the 7 degree of freedom and 5% level of significance, its value comes out to be 1.895 with a negative sign. So the value is of t is minus 1.895. Now because it is the left tail test, right, so this is the critical value minus 1.895. This is the acceptance region and this is the rejection region. And now because this value is less than minus 1.85, so definitely this value falls in the rejection region. So t calculated is minus 4.32, which is less than minus 1.895, so it falls in a region of rejection, hence null hypothesis rejected. Hence null hypothesis rejected. So what do we conclude from here? So we can conclude here that the food B is better than food A. That means, so the conclusion is food B is better than food A, because with food B there is more increase in weight than the food A when we compare their increase in weight. Okay, hence the result. Okay, so these are the problem we have considered for the paired t-test. Paired t-test is used when we are given the two observation of the same set of data, right? Means we are having a paired values, so corresponding to one set we are having two different observations. Then we use a paired t-test for difference of mean, and if we are given two independent samples, then we can use the t-test for difference of mean here. Like in this case, if we are given the two different set of animals, then we use t-test for difference of mean here, right? So in that case we can use the formula that t is equal to x1 bar minus x2 bar minus mu1 minus mu2 upon capital S into 1 upon n1 plus 1 upon n2. Okay, if we are using two different set of animals, so we can solve the same problems with the help of t-test, but because it is written over here that we have to consider same set of animals, so that's the reason we have applied here the paired t-test only. Okay, fine. Now let us come to the next part. Next is the f test. So to understand the f test, firstly we need to understand about f distribution, right? So what is f distribution? F distribution is if x and y are two independent chi-square variate with degree of freedom y1 and y2, then f statistics is defined as a ratio of the two independent chi-square variate divided by their respective degree of freedom also, right? So what does it mean? If you remember, we have discussed that the ratio of the two chi-square variate follow beta distribution of second kind, with the if its degree of freedom is nu1 and nu2, then it is nu1 by 2 and nu2 by 2 only. Okay, so I can write it as, it means that f nu1 upon nu2, this is equal to x upon y, where x and y follow chi-square distribution with nu1 degree of freedom and y follow chi-square distribution with nu2 degree of freedom. So it means that their ratio will follow beta distribution of second kind. So because of that only we need to use the formula of beta distribution of second kind. Its probability density function is 1 upon beta mn x raised to the power m minus 1 upon 1 plus x raised to the power n minus 1, where the value of x varies from 0 to infinity. So here x is replaced with f nu1 nu2. Okay, so that's the reason here we have nu1 by 2 minus 1. Yes, in the formula also here we need to make this correction. Here it is f of nu1 by 2. Nu1 by 2. Okay, so this is the probability density function of f distribution. Okay, so we can say that this particular ratio will follow f distribution with nu1 and nu2 degree of freedom. Okay, so what is f distribution? Because f distribution is the ratio of two chi-square distribution, and we know that chi-square distribution is nothing but the ratio of is the square of standard normal variate. So that's the reason f distribution is also positively skewed right distribution only. Its value is always positive. Its value varies from 0 to infinity only. Okay, so in this case also, when we are applying the testing of hypothesis, we prefer to apply a right tail test only. Till it is not given in the question, we will apply right tail test, but if it is given in the question only, then we apply two tail test. Okay, now come to the f test for the, so f test is basically used for the equality of two population. So if you remember, in the t test for the difference of mean, there we have discussed that we have made one assumption that the two sample variances are equal, that is sigma 1 square sigma 2 square is equal to sigma square. So when we draw the two different sample from the population, so the condition is that their sample variances should be equal. Only then we can apply a t-test for difference of mean. And when we have solved the problems, we have already used this as a assumption that their population variances are equal. But sometime it is not given in the question. So in that case, firstly we need to check the equality of the variance using f distribution or f test only. So what is the purpose of f test? The purpose of f test is to check the equality of their population variances. F test for the equality of the two population variance, right? So what it states, that suppose that we want to test that whether the independent samples have been drawn from the normal population with same variance, or whether the two independent estimate of the population variances are homogeneous or not. And what will be the test statistics in this case? Test statistics is the ratio of these sample variances, capital S1 square and capital S2 square, where capital S1 square is the unbiased estimator of the population variance, that is sigma 1 square, and this is sigma 2 square. And we want to test that sigma, what will be the null hypothesis, that sigma 1 square equal to sigma 2 square equal to sigma square, and the alternate hypothesis is one is greater than the other one. Okay, till it is not given, we always used to apply one tail test only. Okay, that's the reason when we are calculating the test statistics, we prefer to write in such a way so that in the numerator we need to choose only that value of s which is greater than the other one. Okay, so what is the f statistic? It is the sx square or upon sy square, where s square is the unbiased estimator of the population variance. Okay, now let us come to the problem. Okay, so the question is given here: pumpkins were grown under two experimental conditions. Two random samples of 11 and 9 pumpkins shows the samples standard deviation of their weight are 0.8 and 0.5 respectively. Assuming that the weight distributions are normal, test the hypothesis that the true variances are equal against that they are not. So in this case it is given that we need to apply two tail test, right, at 10% level. So what is given here? We are given two sample, n1 is of size 11, n2 is of size 9. Okay, and we are given sample standard deviation s1 is 0.8 and s2 is given as 0.5. So what will be the null hypothesis? Null hypothesis is their population variances are same against they are not. It is already given in the question. So level of significance, it is already given here, alpha as a 10%, but it is a two-tailed alternative, and I already told you that the f distribution is a right-handed screw. So 10% means that 5% we need to, this is the rejection region, 5% we need to remove here. So it means that we need to calculate the left limit as well as right limit, because f distribution is not a symmetric distribution, right? So we need to calculate the value of f corresponding to the degree of freedom nu1 and nu2. We need to calculate the left limit as well as right limit, both limit we need to calculate. Okay, and we need to check that either the test statistics value falls within this limit or outside this limit. Accordingly we are going to accept or reject the null hypothesis, right? So firstly we need to see that which one is greater, s1 and s2. It is clearly visible that s1 is greater than s2, but we need to calculate capital S. So what is the relation? Capital S square is n times small s square upon n minus 1, right? So what is capital S1 square? n1 s1 square upon n1 minus 1. So n1 is 11, s1 square is 0.64 upon 10. So its value is 11 6 का 66, 11 4 का 44, 704. So 704, so it is 0.704. This is the value of s1 square. And what about s2 square? s2 square is equal to n2 s2 square upon n2 minus 1. So it is 9 into s2 square is 0.5 square is 0.25 divided by 8. So this is equal to 9 2 ka 18, it is 2.25 divided by 8. So it is 0.8. Okay, n1 s1 square upon n1 minus 0.61, 11 6 ka 66 plus 1. Okay, let me calculate using calculator only, because we need to ensure that its value should be correct. So n2 is 9 multiplied by 0.5 square equal to divided by 8. Its value comes out to be 0.28125. 0.28125. This is the value of s2 square. And what about s1 square? This is 11 multiplied by 11 multiplied by 0.8 square divided by 10. So its value is 0.704. Okay, so what is the value of f statistics? The value of test statistics or f statistic, f is equal to s1 square upon s2 square, because the value of s1 is more than s2. So, and in this case we need to take the square, that is value only, so it is 0.28125. So if I divide 0.704 with 0.28125, then its answer comes out to be 2.503. So the value of f comes out to be 2.503. Now we need to check that what is the value of f up to 10% level of significance. So we are already given here that, and because in the numerator we have considered s1 having degree of freedom, so the degree of freedom in this case is n1 minus 1 and n2 minus 1. So n1 minus 1 is 11, minus 1 is 10, n2 minus 1 is 8. So we need to check the value of f at 10 and 8 degree of freedom. So 10 at 8 degree of freedom, in the right hand side 5 points, so its value is 3.35. But in the left hand side we are given f of 8 10. Okay, so how we have decided the degree of freedom? If we have taken s1 in the numerator and s2 in the denominator, then the degree of freedom s1 is new 1 and degree of freedom s2 will be new 2. So if we take the reciprocal, then its degree of freedom will be new 2 and new 1. So if we want to calculate the lower limit, what can we use? We can use the one relation of f statistics, that f of new 1 new 2, this is equal to 1 upon f of new 2 new 1, right? But if here we are choosing alpha level of significance, then here we have choose 1 minus alpha level of significance, right? Because probability f of 10 8 is greater than or equal to 3.35, it is already given as 0.05, but we are given probability f of 8 10 is greater than or equal to 3.07. 3.07 is equal to 0.05. So if I take the reciprocal, so 1 upon f of 8 10, then the sign of inequality will change as 1 upon 3.07, this is 0.05, and the reciprocal of f of 8 10 become f of 10 8, right? And this is less than or equal to, so what is the reciprocal of 3.07? If we calculate the reciprocal of 3.07, then its value comes at 0.326 approximately. Its value comes out to be 0.326. So it means that the probability, if the value of f is less than 0.326, then the probability is 0.05. So it means that this is the critical point for the left limit, and the critical point for the right limit, it is already given as 3.35. So the value of f of 10 8 should lies between 0.326 to 3.35. this is the acceptance region, and because f calculated it is 2.503, which falls in the acceptance region, hence null hypothesis accepted. So null hypothesis accepted means that both the sample has been drawn from the population whose true variances are equal. Okay, so what is the null hypothesis? That both the sample has been drawn from the population whose variances are equal, hence the result. Okay, so in case of f test, what we need to do, we are given the sample variances and the sample size is given here. So we need to firstly identify that which one is greater than. Like in this case we find that s1 is greater than s1 square is greater than s2 square. So we are going to choose s1 in the numerator and s2 in the denominator, and its corresponding degree of freedom of s1, because the sample size is 11, so the degree of freedom will be 10. For s2 the sample size is 9, so degree of freedom is 8. So we are going to calculate the value of f statistics corresponding to 10 and 8 degree of freedom, right? And because we are given the table for both, so with the help of this we can get the upper limit, and for lower limit we need to convert this f of 8 10 into f of 10 8, and hence we can get the lower limit also. Okay, let us try the another problem here. The question is, two random samples gave the following result. Test whether the samples come from same normal population at 5% level of significance. Same normal population means their mean and variances are equal. The population mean and population variances are equal. So because here we are given the two independent samples, we are having two independent samples, so in this case firstly we need to apply t-test for difference of mean. But for t-test difference of mean, firstly we need to ensure that their population variances are equal. So firstly we need to apply f test for the equality of variances. So what is the null hypothesis? That both the sample has been drawn from the population whose variances are equal. And the alternative is, because it is not given here, so we are by default applying one tail test. Okay, so what is capital? We are given sum of square, means we are given summation xi minus x bar square, and here we are given yi minus y bar square. We are given the sum of square of deviation about mean only. So in this case I can directly calculate capital S1 square. Capital S1 square is 1 upon n1 minus 1 summation xi minus x bar square. So this is equal to 1 upon 9 into 90. So its value is 10. And what about S2 square? This is 1 upon n2 minus 1 summation yi minus y bar square. So its value is 1 upon 11 into 108. So its value is 11 9 का 99, 90 11 8 का 88, 10 11 9 का 99. So its approximately value is 9.89. Let me check. 108 divided by 11. Okay, so basically it is 9.82 approximately. So you can clearly see that S1 square is 10 and S2 square is 9.82. S1 square is greater than S2 square. Okay, so we are assuming that sigma 1 square is greater than sigma 2 square. So we are applying a right tail alternative. So what is the level of significance? It is already given here, alpha is equal to 5%. So we are using 5% level of significance. And what is the degree of freedom of the numerator? Degree of freedom of the numerator is 9 and the degree of freedom of the denominator is 11. So we need to check the value of 9 and 11 degree of freedom and at 5% level of significance. Okay, we need to check this value. And what about f statistic or test statistics? It is equal to s1 square upon s2 square. Its value is 10 divided by 9.89. So if we calculate this value, 9.82. So 10 divided by 9.82. 1.18, 1.018. Okay, so either we can refer f table, because in this case value is not given, although we can also check its value at with the help of what you can say excel also. So in the excel, if we want to see the value, then we can use the command of f distribution right tail inverse, because what is the probability? 0.05. What are the degree of freedom? 9 and 11. So its value is 2.896. So what is the value? It's 2.896. You are given the value in the form of f is greater than 2.896 is equal to 0.05. In general, we are given value in this particular format, right? So 9 and 11 degree of freedom, right? So it means that if the value is greater than this one, because it is a right tail alternative, so this is the critical value 2.986. so if the value greater than this one, only 5% chances are there. Now because the f calculated is 1.018, which is less than 2.896, so it means that f calculated falls in the region of acceptance, because 1.108 falls in the acceptance region only, na? Hence null hypothesis accepted. Null hypothesis accepted. So null hypothesis accepted means that their population variances are equal. So because this condition is satisfied, so it means that we can apply. So what do we conclude? That the population variances are equal. So if this condition satisfied, now we can apply the t-test for difference of mean. So now we can apply t-test for the difference of mean. So now what will be the null hypothesis? That mu1 minus mu2 is equal to 0, because that both the samples have been drawn from same population. If they have drawn from same population, it means that their population mean are equal. And what about alternative? They are not. So it means the two-tail alternative. Because the t distribution is a symmetric distribution, so we can apply one tail or two tail depend upon the type of the problem, but f distribution we preferably apply a right tail test only, okay, because it is a rightly skewed. Okay, so alpha level of significance is given as 5%, so we need to check the value of t at 5% level of significance. And what is the degree of freedom? In this case it is n1 plus n2 minus 2, that is the sample is 10 plus 12 minus 2, 22 minus 20, 10 plus 12, 22 minus 2 is 20 on. So we need to check the value of t. Two tail 5% and 20 degree of freedom. Its value comes out to be 2.086. 5% two tail with a 20 degree of freedom, right? 2.086. 2.086. Okay, so what is the test statistics in this case, or t statistic? It is x1 bar minus x2 bar minus mu1 minus mu2 upon capital S into square root of 1 upon n1 plus 1 upon n2. So what is capital S square? This is n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2, or This is summation xi minus x bar square plus summation yi minus y bar square upon 20. So because we are already given the sum of square of deviation about mean, so 90 plus 108, so 90 plus 108 divided by 20, so 198 by 20, it is 299.9. so this is the value of s square. 90 plus 108 divided by 20, and then we take its square root. So the value of s is 3.1464. S is 3.1464. So if I substitute this value, the mean comes out to be 15 and 14. So 15 minus 14, we are assuming that their population means are equal, so this is 0. It is 3.1464 into square root of 1 upon 10 plus 1 upon 12. So it is 1 upon 3.1464 multiplied by, if we multiply this particular number with the reciprocal of 10 and reciprocal of 12 and then in their square root, its answer comes out to be 1.34. so this total value comes out to be 1.34. so 1.3472. obviously this number is less than 1, because if I take the reciprocal of this number, its value is 0.7422. 7422, this value is less than the tabulated value. So if we compare, so t calculated, which is equal to 0.74, which is less than 2.086. so because it is a two-tail alternative, 2.086 means that it is basically absolute value. 2.086 means basically it is a absolute value, means from minus 2.086 to 2.086, 2.086 to 2.086. so because this value is less than this one, so it means that t calculated falls in the acceptance region, hence null hypothesis accepted. Null hypothesis accepted. So what do we conclude? That population mean are equal. So it means that, what do we conclude overall? So we conclude that both the sample has been drawn from same population, because population means are equal and variances are equal, hence both the sample have been drawn from same population. So this is the overall conclusion of this question. Okay, so here we have discussed that how we can use effort distribution also for the equality of the variances also, because whenever we want to apply t-test for the difference of mean, this is the necessary condition that both the sample has been drawn from the population whose variances are equal. So this is all about the testing of hypothesis. In the previous video we have already discussed the large sample test, z test for single mean, z test for difference of mean, then t test for mean, single mean, t test for difference of mean, and chi-square test, which is the non-parametric test, and f test. Okay, So if we simply uh, specify here, so large sample and small sample test formulas are almost equal. Large sample, and this side if we consider small sample. So for a single mean, the statistics we are using here, x bar minus mu upon sigma upon square root of n if sigma is known, or x bar minus mu upon s upon square root of n if sigma is unknown. Whereas in t-test we are using x bar minus mu upon s upon square root of n, because in this case sigma should be unknown. This is the necessary condition, because if sigma is known then we use z-test only. Okay, and where expectation of s square is equal to sigma square, means it is the unbiased estimator of population variance. So here this is the formula for single mean, and for difference of means, so we have a z test as x1 bar minus x2 bar minus mu1 minus mu2 upon sigma into square root of 1 upon n1 plus 1 upon n2 if sigma is known, and if it is unknown then x1 bar minus x2 bar minus mu1 minus mu2 upon square root of s1 square upon n1 plus s2 square upon n2 if sigma is unknown, where s1 and s2 are the sample standard deviation. And if t-test for difference of mean, then we can use x1 bar minus x2 bar minus mu1 minus mu2 upon capital S1 upon n1 plus 1 upon n2. So here we have a degree of freedom n minus 1, and in this case you have a degree of freedom n1 plus n2 minus 2, where s square is equal to n1 s1 square n2 s2 square upon n1 plus n2 minus 2, or summation xi minus x bar square plus summation yi minus y bar square upon n1 plus n2 minus 2, or n1 minus 1 capital S1 square n2 minus 1 into capital S2 square upon n1 plus n2 minus 2, where expectation of S1 square equal to sigma 1 square and expectation of S2 square equal to sigma 2 square. Not sigma 1 and sigma 2, rather they are same. This is the necessary condition. So this is the necessary condition, that sigma 1 equal to sigma 2 is equal to sigma square. This is the required condition if we want to apply t-test for difference of mean. Okay, and apart from this we have a t-test for the paired t-test, which we have discussed in this particular video only, and F distribution for the equality of variance we have already discussed in this video. And apart from this we have a chi-square. In our syllabus we have a chi-square for the goodness of fit only, so there we use observed and expected frequency formula. Okay, so that is all about testing of hypothesis. So if you have any doubt or any query, you can post your query in the comment section. Thank you and all the best.